Hello and welcome everyone. So Llama 3.3 models have dropped. It has been a couple of days and I did a video around function calling capabilities of Llama 3.3 models and I use a terminal based benchmarking suite for that purpose. However, I realized that that benchmarking suite wasn't as comprehensive. So what I've done within these last couple of days is to build a very comprehensive function calling benchmark suite for large language models. And not only can it do benchmarking for one single model, but you can use it to test two different models' capabilities in terms of tool calling or function calling. So let me give you a very quick demo. Like if your Llama server is hosted on your local host and your model that you want to test is Llama 3.2, let's say, I know I'm going to show you Llama 3.3 comparisons and all that later. But if let's say you are testing model 3.2 right now and you want to run it for 10 different iterations, and I'll talk about no tool probability later on, but let's enable this debug, this detailed logging, click on generate, and you will see that there are 10 different sentences that were randomly generated over here. And it is expecting, these sentences are expecting the get current weather tool to be called. So I'm going to go ahead and click on start benchmarking. And you'll see that this kicks off the benchmark process. And the very first benchmark time takes a little longer because, of course, the model was being loaded. But it shows us various different statistics for these 10 iterations or 10 sentences that were generated. So each one of these sentences, for example, is it going to rain tomorrow in Houston, was sent to the large language model, to Llama 3.2 model over here on my local host, and the expectation was to get a get current weather call was an expectation over here, and you will see that all the 10 calls were successful, and there is the overall statistics that tool expected 10, 0 failed, pass rate was 100%, and below are the detailed logs at exactly what happened when the tool was called. So you'll see that for this particular base URL, model name, this was the sentence, and expected tool call was get current weather. And this is actually what happened in the response. The name get current weather and the location of Houston, Texas was passed also, you can see over here. And the output that the model did was with the actual response over here. So what we're doing is, in the background, actually, I have exposed a slash benchmark endpoint. And you will see that all these 10 calls were sent to a fast API server where slash benchmark endpoint is exposed. And this slash benchmark endpoint, let me show you the code around it too. So this slash benchmark endpoint accepts a function calling behavior over here. So I've used LangChain in the background over here, where you can configure your chat Llama for configuring your model. And this is where let me show you this over here. This is where the base URL and LLM model name are being passed. So let me show you the code. In the code, you will see that there is a benchmark request object where the base URL and model name is being passed and the sentence that you are processing, right? So the request that the user has is also being passed, and the expected tool, which is weather tool, is passed over here too. So I made this particular model, I made the chat Llama model over here accept tools. So two tools, which are get current weather and get system time, have been made available to this particular model with tools. And now we are just initiating or we are invoking this particular initial request by passing the sentence to this particular model that has two tools available to it. And if you want to know more details around how to use Chat Llama or how to use the function calling capabilities with Llama, this is a very good article over here. So python.langchain.com docs how to tool calling, and this shows you the version 0.3, which is the latest version of the LangChain for tool calling. And this is a very nice article that shows you how you can associate tools to your model and then how you can invoke tools also, which is what I've done in the use case over here. So what this enables us in doing is we can plug in different base URLs over here and different models over here. And if you have, let's say, multiple instances of Llama hosted, then you'll be able to do comparative analysis of these models. So let me do that. So I have actually two different Llama instances with me available. So one is this localhost machine right here, and the second one is my AI server, which is in the basement. So I'm going to be putting the AI 11434, which is my basement Llama server, and I'll do Llama 3.3 over here. So we'll do a comparison between Llama 3.2 and Llama 3.3, and let's run it for 25 iterations, and then let's see what happens. So I'm gonna leave the no tool probability as 0. I'm gonna click on generate, and I'll start the benchmarking process over here. And you'll see once I do that, there are now two different results that are showing up over here. So one on the left hand side is the first LLM configuration, which is Llama 3.2, and then on the right hand side there's the second LLM configuration, which is Llama 3.3. And Llama 3.3 over here, you can see that it is being loaded on my AI rig, which is what I'm showing you. So there are 4 GPUs 3090s over here, and they are being loaded and processed. So we can see that all these sentences, they are being processed, and there are actually no failures up until now for 10, 12, 13 sentences, which is awesome. There have been no failures, which is good. And both Llama 3.2 and Llama 3.3 are working almost equally, if not exactly equally. The only difference being the time taken by Llama 3.2 is in 250 milliseconds or less, whereas the time taken by Llama 3.3 was about 2 seconds for the same function call. So nothing failed over here, which is awesome. And this is what I saw in my previous example too, that when I was attempting function call, the model was respecting that. It was making an actual function call. And if you want to go down and check for both these models, so the function call was done perfectly. So the name of the function, you see the way the tool calls was done, it was done perfectly over here. So get current weather, and it was formatting the requests also. You can see that the requests formatted by your Llama 3 model over here, the 3.3 model over here, is more accurate because it needs to pass in both city and state, which is what it is passing over here. So the response from the Llama 3.3 is more accurate. Let's scroll down and see if there are more inconsistencies or not. So Nashville, it was formulating perfectly, which is good. And the location over here is being done perfectly also. So in trickier situations where you have Washington, DC, DC, it actually formatted better. The Llama 3.3 formatted that better than not. So you can see I did a comparison over here in past also. Both these models are actually working pretty good over here. If there are if there is an expectation of tool call and a tool call is done over here, the problem or the differences that we start seeing is when we insert certain statements which do not expect a tool call, but tools are available to model. What do I mean by that? So let me put a probability of 0.5 over here, click generate again, and you will see the sentences that are generated now are mix of both. So there are some sentences where we are asking for temperature or weather related data, and an expectation over here is that get current weather method will be called for this one, whereas there are some other questions that we are asking the model, like what is 2 plus 2? There is no tool call that is expected. So the expectation is no tool call should be done over here. And then there are some other questions that do expect tool calls, some other that do not, right? So give me a fun fact about penguins, no tool call is expected. And then these are just randomly generated sentences, and then they may repeat also, which is okay. These are just fixed set of sentences that I'm randomly inserting with 50% probability. And out of 25 sentences, about 12, 13 sentences now should be non-tool call related sentences. And let us hit our benchmarking with 3.2 and 3.3 with half of the sentences being no tool probability over here, right? So let's do a start benchmarking step over here, and let's see what happens. So when the tool call, so there you go. So the sentence number 4, 5, and 6, let's take a look. So 4 is give me a fun fact about penguins, and this failed. So our Llama 3.2 failed over here. So I'm pretty sure it must have attempted to do a tool call, even though the tool call was not necessary at this point. So let's see. I'm gonna scroll down, and I'll actually let the test suite finish, and then I will show you some details around it over here. Okay, perfect. Look at that. Llama 3.3 perfectly had 25 success, 0 failures, 1.3 milliseconds of time. Because the model is already loaded, the very first call is now not bogged down, and that is why the average is a correct average being shown over here. But if you see over here, we had 4 failures. Where are those 4 failures coming from? Let's scroll down and see the overall statistics section. So you will see when the tool was expected, 17 success, 0 failure, right? So which means there were 17 calls where the tool was expected and the tool call was done. Whereas when the tool was not expected, there were total of 8 such calls. 4 of them passed and 4 of them failed, right? So you can see 1, 2, 3, 4, 5. Let's scroll down, 6, 7, 8. So these 8 calls did not expect tools. However, out of those, 4 of them incorrectly did a tool call. And if you want to see which were those calls that failed over here, you can toggle this as show only failed logs. And you will see that in Llama 3.3, there are no failed logs, so nothing is being shown over here. However, in Llama 3.2, you can see when you asked, give me a fun fact about penguins, I'm pretty sure it attempted to, do a current weather for location South Pole, right? So this is not a correct function call over here. You cannot get a fun fact about penguins by doing a current weather on South Pole. Good try though, nice try model, but doesn't work like that. Then describe a beautiful scene, and it is again trying to do a current weather, and it is just giving random parameters that is not expected over here. Let's go down, describe a beautiful sunset, and it is again trying to do a get current weather of a suburban area, which is not right. Again, 3.2, what is 2 plus 2? And again, doing a get current weather for Woodbury, which is not right. And these were the 4 calls that failed for Llama 3.2. Very unfortunate, but this function calling test suite very clearly shows us the differences. So even though we think that if we have associated tools to a model, model will only be invoking tools when it is necessary. It is not always the case. The model does incorrectly tries to invoke tools when it is when the tools are not necessary, which is a problem for us. So you know what? Let's go ahead and switch the 3.2 Llama 3.2 model to a higher quantized model, right? So many times we think that, hey, maybe it's the quantization that is affecting us. So let's change this to a higher quantized model. Instruct Q8 instead of Q4, which is the default. And let's generate sentences again, and let's just run this benchmarking suite again. And you know what? To make it fast, I'm gonna delete the 3.3 over here so it can run fast, right? And let's hit the benchmarking again. And Oh, looks like I do not have probably instruct Llama 3.2 3b instruct. Oh, it got there twice. Okay, all right. Let's hit it again. Let's send it again and let's see. So for 3.2 3 billion instruct, almost the same story. Almost the same story, right? You see so many failures over here, and one success and 10 fails for no tool expected. This is where the model, the 3.2 model, actually struggles. It struggles where a tool call is not expected, and so you see all these calls where we are saying tell me a joke and all that. So out of the 11, right, out of these 11 sentences, 10 of them failed over here for us, which is very, very unfortunate for 3.2 model. Let me make some more comparisons. So what I'll do is AI colon 434, and I'll Llama 3.3, and we'll take Qwen model now over here to do some comparisons. So let's compare Qwen2.5-Coder. This is one of my favorite models. Like, trust me, I absolutely love this model. It definitely outperforms in every tasks all the time. So what I'm going to do is regenerate 25 sentences, zero point 0.5 probability of getting some different sentences over here. So tool calls are not expected, and there are a bunch of sentences generated where tool calls are not expected now. And let's start the benchmarking again. So first, the model has to be loaded in our RAM over here, in the VRAM over here. So let me show you also the local system GPU. So there are these two GPUs that are on my local machine. So these are the two GPUs right here. I'm gonna keep them maybe a little bit like this, so you can visualize this as well. Okay, so the red is Qwen and the black is your 3.3 Llama 3.3 model over here. So let's see. So the Qwen model is now working hard. No failures, that is pretty good. No failures over here, that's also good. So these two models are competing with each other. So let's keep going. Both the models are doing pretty good. So 10 successes, 0 failures. Oh, Llama 3.3 failed one of those, and so it is behind now. It's behind Qwen model over here right now. Okay, let's see. Let's keep on going. And usually Llama model, this model doesn't fail. I mean, I know that Qwen performs really good, but the Llama does not fail usually. So this is an unexpected surprise for us. And we'll analyze the failed model, the failed question also, and see what happened over there. But let's have the test suite finish and the results come back, and then we will analyze it. Look at how nice Qwen model is. This is absolutely awesome. 25 0 failures, and wow, this is awesome. Okay, so let's see which one has failed. So sentence number 10 failed. Let's see sentence number 10. Give me a fun fact about penguins. Okay, so this time around it could not do it. So let's see. Show only the failed logs, and this is where we can see the failed log for us. So fun fact about penguins, and it tried to run get current weather. All right, you cannot get a fun fact about penguins by running the current weather. All right, so one more thing that I want to check is, will Llama 3.3 and its higher quantized version, right? So my GPU in the basement, I have 4 NVIDIA 3090s, and let's see if 4 NVIDIA 3090s can take the Q8 version of Llama 3.3 model or not. So I have already downloaded it, and let me load this particular model. So you will see the model, the current model got unloaded, and now over here you will see that the model for 70B instruct Q8 will start getting loaded. So it will take close to 80 gigs of VRAM, and I have around 96 gigs of VRAM over here on this server, so I think it should be fine. So let's see, all of these four GPUs are getting loaded with this model. Awesome, it's loaded now. It took about 32 seconds to load the model, so very first request is longer, even though it is not really 32 seconds of response time. Wow. So you can see that the Qwen model continues to outperform our Llama 3.3 70 billion instruct even at the Q8 quantization, whereas Qwen2.5 at Q4 quantization is beating the Llama 3.3 70 billion at Q8 quantization. And keep in mind, I'm only considering the function calling capabilities of the model, but still it's a valid one-to-one comparison where things that Qwen model is currently doing, Llama 3.3 even at Q8 is unable to do. And I know it's a very specific use case. I use agents a lot, so for my use case, this matters a lot. So if I have to choose between these two, I mean, is Llama 3.3 good for as a generic model that can do everything? Yes, but so can Qwen2.5-Coder as well. So maybe unless and until I need some higher reasoning capabilities of Llama 3.3, I'm better off with the Qwen model itself. Wow, look at that. 25 0 failures, whereas 22 and 3 failures. So let's see which instances failed. So whenever tool was expected, a tool was called, which is nice, right? Tool was expected and tool was called, 0 failures over here, 100%. When no tool was expected, then tool was not called, all 13 successes over here. But when no tool was expected, even then 3 times Llama model continued to call the tool. And let's see only the failed logs over here. So 70B instruct, what is 2 plus 2? It's trying to call weather tool, which is not right. Let's keep going down. Give me fun fact about penguins. Again, trying to call the weather tool. And give me a fun fact about penguins, and again trying to call the weather tool over here. All right, so this is a little unfortunate for us. So while generating the test suite, if you actually want to change the question over here, you have the ability. So this is one of the functionalities that I want to show you. You have the ability to just modify the question. So you can ask, what is the system time, or anything, what is the system time, and let's say if you are expecting no tool to be called over here because of this, then you can just configure this thing also over here like that. So there's just some capabilities I have built in this function calling testbed for us. And you can also change this node tool probability to maybe 1, full on 1, and you can generate it. So all the questions now become with 100% guarantee that there are no tool calling capability over here. And you can start a benchmark with this also. And we can see how many times Qwen actually fails. So this is a more rigorous benchmarking for Qwen and for Llama 3.3 because this is the use case where they are actually failing, if at all they fail. So let's see. So Llama was doing good up until, but 1 out of 4 it failed. So let's keep on going and let's keep on seeing what happens over here for both the models. So again, 2 failures for Llama, 0 for Qwen, which is expected. Let's keep on going over here, and while the suite is running, what I'll do is I'll see if I have a Nemotron model in the basement or not. So the easiest way for me to do that is to go and just go to my OpenWeb UI over here and just log in to OpenWeb UI and just check if I have Nemotron. Yes, I do have Nemotron. And do I also have some other models? I have DeepSeek-Coder, but that doesn't use, that DeepSeek-Coder does not use the tool calling, which is unfortunate. Mistral-Large. So we can do a test on Mistral-Large as well. Let's do that. Let's do that. I'm not sure if my benchmarking suite is optimized for Mistral models, but I hope LangChain will take care of that. But take a look at this. So no tools expected, 21. And 4 failures over here. That is so sad. That is so sad for Llama 3.3 because I really wanted it to succeed over here. But look at Qwen 2.5 again, being a champ over here. When no tool is expected, no tools were called, right? This is what we want. Tool is not expected, so tools should not be called. It is really, really, really awesome. No tool expected and no tool called. All right. So let's do the same test for Mistral-Large. The only problem is Mistral-Large model is very slow. So let's see. Mistral-Large and not, let's do it 0.5, generate again. And let's do this 10 because I know it takes a lot of time for Mistral-Large to actually generate responses. And I'm not sure whether my code is optimized for Mistral models yet or not, but we'll find out. What else we'll do is we'll use Nemotron because I know Nemotron is one of the best models that I have ever used. And I am like, just as much as I like Qwen2.5-Coder, I enjoy working with Nemotron too. So NVIDIA has done some kind of magic with Nemotron. It really works very good. All right, so let's have the Mistral-Large load over here. So let's see. It is taking some time. Mistral-Large is a pretty big model, 123 billion parameter model. And it is starting to load. Let's give it a little bit more time. Give it a little bit more time, and the first response you will see will be quite a bit longer in time. So you can see that the GPUs have kicked in, and I have actually, if you see the whole NVIDIA SMI is over here, I have moved it on the side so that we can see the relevant section only, and we do not have to take a look at everything that it shows us. So 76 seconds for the very first load. All right, so the Mistral-Large, so LangChain is doing its work, so it is helping me out over here, but Mistral is it's working. Yeah, Mistral-Large looks like it is also a pretty decent model over here. All right, if it works, then what I'm gonna do is I'm gonna test Qwen and Mistral-Large, and then we'll see if they both, which one is better. So Qwen has been better regardless up until now. It has not failed yet, right? It has not failed in my benchmarking yet. So let's see. Let's see some more results. I know we started with Llama 3.3, but Llama 3.3 has failed already in multiple instances. So I'm moving on to Mistral and Qwen as competitors over here. Wow, so both of them 100% success rate. So let me increase it to 25 and let's do a generate again, and let's do a start benchmarking again, and let's see. So the interesting part is both the models, Qwen and Mistral, they are taking decent amount of time, but still Qwen is almost half of the time than the Mistral model. So you can see that Mistral also sometimes takes less time and sometimes it takes more time. I think it is because the function calling is in a way a subset of the actual response that is generated. So it is generating a response, and that response is being casted by LangChain into a smaller function call, and that is why sometimes we do get a longer time as a response and sometimes we get a shorter time as a response. All right. So while this particular test suite is running, I want to show you this repo. So all this code I have made available in my repo over here. So LLM Benchmark Suite over here. The way I am running this currently is by utilizing a Docker container. So you can see that there is a static section over here which has 3 files. So there is index.html, script.js, and style.css. And these 3 files, they are being hosted by a fast API server that is right here in main.py. So in main.py, you will see that there we are hosting our static files right here. So in the /static directory, when you try to serve slash, you get static / index.html. And then all of that in UI magic that you see is between these 3 files. Now, these 3 files over here, mostly the script.js file, you will see that this is interacting with another endpoint that we are exposing in our fast API server. So what is that endpoint? That is this /benchmark endpoint. And this endpoint, what this is doing is it is accepting benchmark request as our, okay, I do not want that. All right. So it is accepting benchmark request as an input parameter. And benchmark request is base URL, model name, sentence, and expected tool. And this particular benchmark request is nothing but configuring our chat Llama and also binding tools to this particular model that chat Llama has configured, and then sending the sentence as a request to the model, and then expecting a tool call. And then if the tool call that the UI, in the UI, we have already said that what particular tool call is expected based on this. So we are making a comparison. We are doing a comparison over here. We are checking whether the tool call that was expected is being done or not, or is the model incorrectly calling a tool that it is not supposed to do. So all that logic is happening over here. And then once we have the final response back, we are building this response and we are sending it back. So we are using only 2 status codes, so 200 and 500. Maybe 500 was unnecessary over here, but these are the 2 status codes that we are using, and we are sending the data back or response back to the UI. And then UI is getting everything back in the script.js file, and it is putting everything together till the whole test suite is finished and running. All right, so looks like we have we are stuck with a particular response generation from the Mistral-Large model at the 12th sentence. So let's see what the 12th sentence was. There you go. So 12th sentence is, can you tell me the forecast for tomorrow in San Diego, California? And it is really trying to generate some kind of long output for this. And which is where it is taking a lot of time. So we'll let it generate. And we'll find out. But this is where sometimes when these models start being chatty, it feels like they are stuck, but this is not really stuck. It is actually trying to generate a response for that. I'll pause the video over here for a little bit till this model is done responding back, and then I'll continue from that time. All right, so I have waited for a very long time now. I think it has been at least 10-15 minutes, and this is still stuck at attempting to generate the response for this model. So what I'll do is I'll actually kill the Llama server over here so that it stops generating the response, which will mess up this particular stats. But so Docker restart Llama, which will kill that particular request. And it will reload this model over there, and that will fail this request, which is okay. which is okay. But it will reload the model, and then it will continue from that side. So let's have it reload the model and continue with the benchmarking. And we'll count this as a failure because of course it is a failure. I don't know what model was doing, but it was really trying to generate an attempt to generate a very long response, or it was stuck. I don't know, not sure. So Mistral-Large is being loaded again. So after Mistral-Large, let's see what other models can we check. So definitely we're going to take a look at Nemotron because Nemotron, definitely one of my favorite models. So we'll give Mistral-Large the chance to process all these requests. And I'm sure, I mean, except for that one glitch, Mistral-Large is a very good function calling model, and it should have just one failure, the one that we saw, and apart from that, it will be performing pretty good. And I wouldn't be surprised to see 100% success for Mistral-Large as well. And I mean 100% minus one, right? And which is the case. So there are some features I have built in, like you can pause at any time one side of the model and then have the other one continue to run and finish and then resume this one. So there are other features that have been built in, but I like seeing these requests happen parallelly at the same time, so that you can see what is going on over here. So there you go, 9 success, 1 fail, and a pass rate of 90%. This one failure that we see for Mistral-Large is only because it got stuck attempting to generate a response that it shouldn't have. Okay, so Mistral-Large, we'll give it as a good high score, pretty decent model, good score over here. So let's keep Qwen2.5 as our current winner in LLM1, and let's see if Nemotron can actually beat Qwen2.5-Coder. Okay, so generate, start benchmarking, and let's see Nemotron. So Nemotron will be loaded on all 4 GPUs now, and we'll also take a look at our Qwen model on the top and Nemotron on the bottom. And let's see once the model loads over here. It is still loading. The model is still loading. It still says 4 megabytes. And there we go. So about 40 gigs of the model. I think it loads at about 44 gigs, if I'm not wrong, 44 to 45 gigs. So we will see 11 gigs on each one of these. Yep, there we go. The model has loaded. And I'm pretty sure that Nemotron will also have equivalent results as Qwen2.5-Coder, because both these models have been amazing up until now. But I'll double check and see. Nemotron was built on Llama 3.1 70 billion parameter. So but it was improved upon that. So you can see the response times over here. 4 seconds of response time. Nemotron is one of the chatty models, right? So it does its in-depth, analysis before it actually generates a response. So after we are done with Nemotron, I think the next model that I would like to choose, let's see, Marco O1, QWQ. Let's try both of them, and then is there anything else? Llama 3.2 Vision 90 billion. We'll see. We'll see if we want to do that. DeepSeek Coder, Hermes 370B, Fire function. We can try that too. Command R. We can try that one too. Let's see. All right. We have a few models that we can play around with. Let's see how the current Nemotron model. Wow, it is good. It is decent, good model, but takes a lot of time. Definitely takes a lot of time to generate some responses over here, and it of course does, because it is a very chatty model, like I said. So it is generating a lot of tokens. which are getting converged into a function call later on. All right, so what I'll do is I'll let this model run and finish over here. I'll pause the video and I'll have it finished, because if it's gonna take 21 seconds for every run, then it is a lot of time that it will take. So I'll pause the video and come back when it is done. All right, so it is done, and as expected, Nemotron is a beast of a model, just like Qwen is. The only difference being the average time for responses. Look at that, 12 seconds as compared to 1.5 seconds for Qwen model, right? So this is definitely in favor of Qwen models. Not only it is performant in terms of response time, it is also 100% success rate over here. Okay, let's see. Let's compare some other models. Let's keep Qwen as our leader up until now, and let's go to some other models. Let's see if we can have Marco O1 model. I don't even know if it can do function calling or not, but let's see. Let's find out. Marco O1. On our remote server over here, let's do some generate, start benchmarking. And yeah, pretty sure Marco does not do function calling. So that is why it is failing over here. Let's take a look at some logs. Marco does not support function calling or tools. So makes sense for it to fail. And this is where we will stop this and stop this. We don't need to proceed any further if it cannot do function calling. Let's switch to something else. QWQ latest. Let's do that. So QWQ, that should do function calling. Let's send the function call requests to QWQ. And the very first request will take time because the model gets loaded, but it should get loaded pretty fast. And we should see the first response come back now, approximately now. I think it's loaded now. Okay. All right, so while it's getting processed, let me just take a look at some other models that we have. No, I originally wanted to do that, but I'm going to skip this. The vision models for our test cases. Hermes 3, which is Llama 3.1. And actually, you know what? We'll do a Llama 3.170 billion directly. Also, we'll compare that with Qwen model, because I've been told that Llama 3.1 apparently was better performing than Llama 3.3. Some people said that, and I do not know that. I'll put it to the test over here for us. Okay, so this is nice up until now. QWQ versus Qwen. QWQ is also holding up for first few requests. It's holding its ground. Let's see. The only difference is that look at the time. Look at the average time for this, right? I mean, definitely beats everything in average time. And yeah, this average is getting messed up because of the very first load time, right? So we'll give it a little bit of grace for that. But QWQ is all over. Right? It is all over, whereas it is a very consistent 1 to 2 second response. Wow! Okay, so the Qwen2.5-Coder failed. Sentence number 6. What was that? Describe a beautiful sunset. It failed to describe a beautiful sunset. Wow. Okay, so the coder failed to describe a beautiful sunset. It tried to do a system time. Ah, that sucks. So yeah, that really sucks. I mean, it interpret sunset as some kind of timing. It was a tricky thing, and it tried to invoke a system time over here. And we have given multiple tool access to Qwen2.5-Coder, but still, QWQ did not fall for it. QWQ actually did the right thing and did not do a tool call over here, but Qwen model actually gave up, and it then eventually did a tool call. So the very first failure that we have seen in the Qwen model, once after hundreds of messages that it has processed, it failed for the first time for us. All right. Okay, so that is interesting to see. And after this, we will we'll do command R plus and fire function v2 also potentially, and then we'll see the results. All right. Wow, the time taken by some of the models is insane, like 10 seconds long. QWQ does like a lot of tokens to be generated, so that's expected, but still, some of these models do take a lot of time. All right, so this processing is almost getting done, which is nice. So Qwen, except for that one failure, is holding its ground, and the QWQ is also pretty good. So very, very nice, 100% success over here, right? But the Qwen model for the very first time failed, and QWQ did not. But I mean, happens to the best of us. So Qwen, it's okay. Don't feel bad about it. You're fine. Let's keep going. Fire function v2. So that is something that I want to test also. So let's see. Fire function hyphen v2, and we'll put that on here now. And let's send it, and let's see what happens. All right, so the model is getting loaded, and then we are testing fire function v2 and checking how does that react. All right, so model loaded, and actually it is pretty good. Fire function is meant for this purpose, for function calling, and wow, really good, really good response. Let's see, number 10 was success. Wasn't supposed to do a function call, did not do a function call. Very nice, very nice. Let's take a look over here too. It is index 4, 5, 6, 8, 9, and 10. Very nice. 2 plus 2. It did not do a function call over here. So very nice. Okay. Oh, it failed at number 18. All right. Number 18, give me a fun fact about penguins. And then number 20, beautiful sunset. It passed the next beautiful sunset, but it failed the first one. Look at Qwen2.5. This is absurdly amazing. Wow, 0 failures. Wow. Okay, let's take a look. Which things did fire functions fail? So it failed for 3 instances. Tried to get beautiful sunset for get current weather, and about penguins, tried to get system time. Okay, and describe a beautiful sunset, and again try to do a weather call for beautiful sunset. Okay, all right. Again, clear winner, Qwen2.5-Coder. And there was one more model, command R plus, for 104 billion parameter model. Let's run it also. I think this is how it is spelled. Let's double check. Command R plus. Yep, that's it. Let's put it to test 2 and let's see whether it can perform at least as good as Qwen model or not, Qwen 2.5 model. So QWQ and Qwen, these are the two models that have been outperforming any other models. So just putting it to its test again. So the model is getting loaded over here. The command R plus being 100 plus billion parameter model definitely will take a little while to load. While it is loading, let me quick show you how can you run this application if you want to run it. So the easiest way to run this application is to just do a git clone. And the instructions are all in the README file over here. So you can do a git clone, and after that you can install the requirements and then just run this application, as simple as that. However, if you want to do it even more simple and easier, I would recommend running it using Docker. So you can do a git clone, cd into it, do a Docker build, and then just run this particular command over here, and that's it. And while you are doing the build, the Docker container called LLM Benchmarking Suite will get created. And then when you run this particular Docker container, you can then access from localhost 8090 because you are exposing the port 8090 from within the container to outside, and localhost colon 8090 will show you this particular UI that you are looking at. And this is actually how I am running it too. So if you want to see, there is the same Docker container over here that I have. So it is, not over here. Where is my Docker? Oh, right here, right here. So my Docker container is running right here. So these are all the requests that have been sent, and the Docker run command is all the way on the top. So let's see if I can reach. Nope, I cannot reach too much. Okay, let's go back to the benchmark. And whoa, Command R plus also had a ton of failures. Wow. Okay, so it passed for many sentences, but it started failing for, I believe, the non-tool call ones, because that's where many models start struggling. So let's see, I'll let it finish, and then we'll see the statistics at the bottom. So yep, there you go. So tool expected, 12 success, 0 fail. Tool expected, 12 success, 0 fail. No tool expected, 3 success and 10 fails, right? So the tool was not expected over there, but the model attempted to do the tool call, which is unfortunate. Okay, let's see the failed calls over here. Describe beautiful sunset and name directly answer. Tell me a joke, name directly answer. Oh, okay. So it has its own way of saying that what kind of tool call it is doing. Okay, describe a beautiful sunset, directly answer. All right. So it wants to invoke a tool called directly answer instead of actually invoking a tool. That is actually pretty impressive. I will actually give it a pass in that case, because it is identifying that these are the instances where it has to directly answer. And wow, that is pretty amazing. It is trying to invoke a tool called directly answer instead of, but I mean, this tool doesn't exist, so of course it is a fail. But I kind of want to give it a pass over here because of that. Okay, I think that is it. Dolphin-Mixtral, should we do this? 822. Let's do this. Let's do this as the last test, and then we'll call it a day. So Dolphin-Mixtral 822. Was that the name? 822B. Dolphin-Mixtral 822B. Okay. Generate, start. And the beauty of Dolphin-Mixtral is that even though it is a big model, right, it only invokes What happened to you, Mr. Model? Model invocation does not support tools. Oh, that is interesting. That is very interesting. Hmm. Very, very, very interesting that Mistral 822B does not support tools. Wow, okay. And Llama 3.170B, shall we do it? Let's do it. So I'm gonna do Llama 3.3 and Llama 3.170B. Okay, so these are the two servers. Actually, I can run both of them in the basement server. So I have a 11436 and 11435. So there are two different Llama servers and they can execute this. So let me generate 25 more sentences, 0.5 probability, and Llama 3.3 is going to be on the left side, and Llama 3.1. You know what? Actually, let's have the 3.3 on the right side and 3.1 on the left side. Okay, generate, start benchmarking, and it'll take the first two GPUs that are on the top over here as 11435 and bottom two GPUs as 11436. So Llama 3.3 will be loaded over here in the bottom two GPUs, and Llama 3.170B will be loaded on the top two GPUs. Okay, let's see. Let's see how the model behaves now. So this is going to be a very interesting comparison because I've been told in one of the previous videos that Llama 3.1 actually was beating Llama 3.3 in function calling. So let's put it to test and find out. The very first call, of course, it will take some time. The model is getting loaded over there. So we'll give it some grace, and 60 seconds, about a minute, the model took to get loaded. And let's see how long it takes to load the 3.3 model over here on the bottom two GPUs. It takes just a little bit for the model to get evicted and loaded over here. So the model is loaded now. You can see it takes a little bit, about the same amount of VRAM actually. If you see 23 and 22, about the same amount of VRAM. Okay, so let's see. The very first sentence takes how much of time? This one took about 60 seconds, including the model load. And let's see how much this one takes. Taking some decent amount of time for the very first one. 64 seconds. Okay, so definitely goes to 3.1 to load faster than 3.3, which is all right. Let's keep on moving forward with the responses that are going to be generated. So I'm assuming it'll take about 5 seconds, even though that time has passed. Not 22 seconds. Wow, Llama 3.1 took 22 seconds for generating that response. That is quite a lot. All right, so let's see, 3.3, 16 seconds. Okay, so faster than 22 for sure. Let's keep on moving forward. I think with this rate, I'll have to pause the video here for a little bit and then we'll come back. Not sure what's going on over here. So this is painfully long. This is painfully long. So every request is taking like 30 seconds to a minute over here, which is not not doesn't look right. So what I'm going to do is let me do one thing over here. So I will SSH into my remote server and I will restart those two Docker containers. You know what? Let's restart them. Those two requests will fail for one each, and that's okay. That's acceptable. And let's see. Failed on one side. And let me also. Oh, so this is what was happening essentially. So not the whole model was being loaded over there. All right, okay. So I'm gonna restart all three Llama servers, um, which in turn will kick in full load of these models on the backend server instead of only partially being loaded and then partially loaded in the RAM. So it wasn't loaded in the VRAM because Llama 1, well, without the one, the Llama server was consuming some resources also over there. That makes sense. Okay. So hopefully the processing will be faster now. If not, then I'll have to kind of shut down this particular test because this is unbearably slow for us. Yeah, no, this is fine. See this. Okay, all right. This is an expected time frame for us to get the results back, not 26, 29, and 60 seconds and all that. So I'm going to rerun this test actually so that we can have some reasonable responses back after this. I can actually stop these two tests and then restart them because that wasn't really something that I was expecting. Okay, so I'm going to start the benchmark again. And this time it will take reasonable amount of time, which is a second each, which is good. Um, which is good. So 3.1 failed when 3.3 passed. All right, let's keep going. 3.3 versus 3.1. Very good. We did see one failure for 3.1 this time around. Two failures for 3.1. Okay, we'll analyze them after. We'll analyze them after this call ends. So 17, 18, 19, 20, couple more. 3 failed. Okay, all right. Quite a few of them failed then. Okay. And then we had 2 failures towards the end over here too. Okay. So the most failures that happened were for no tool expected, 14 success, 3 failed, and no tool expected, 15 success, 2 fails. And you can see that Qwen never fails or almost never fails in these instances. So let's see, let's take a look. So show only failed logs, and we can see how we have 2 plus 2. Oh, no tool required, it said, but attempted to call a tool called no tool required. Okay. Again, fact about penguins is a get current weather for it. Beautiful sunset is get current weather again for it, which is not right. 2 plus 2 get current weather not right. And fun fact about penguins, get current weather not right. Okay, all right. So This is what my LLM benchmarking suite is. I'll encourage all of you to check this out. There is a dark mode, which is what I've been using throughout. There is a light mode also, but nobody likes light mode. So dark mode is what we're going to use over here. Please check this out. Let me know how you feel about it. If there are some enhancements that you would like to suggest to this tool, please let me know and I'll make some more enhancements to it. But as it stays right now, I am very happy with how this tool came out and how it can do comparisons on the real time uh, for checking the function calling, behavior of a large language model or two of them and then compare them. Um, Thank you all for watching this video. And if you have stayed till this long, then maybe you would also be interested in subscribing to this video and liking this video too. I don't usually ask this, but I've heard that if you do ask, then people do like and subscribe. So I'm going to do that from here on. Thanks everyone for watching this. I'll see you guys in next one.